So good evening to all. So as part of CompMusic workshop, so I'm going to present my work on scent filter banks and its relevance to Carnatic music. So outline of my talk will be, so initially first I'll talk about importance of tonic with respect to Carnatic music. So once we know the importance of tonic with respect to Carnatic music, then we are trying to define a problem definition. If you wanted to model any Carnatic music segment, is it possible using general filters like male filter bank based capsule coefficients? Because here we have to do something with the tonic information. So after that, once I'll try to define what's the problem with general male filter banks. Then I'll try to define a new feature, as already Hema ma'am has discussed, scent filter bank based capsule coefficients, so which will take care of tonic information with respect to music segments. Then we have applied scent filter banks on different types of music processing tasks, like song identification in Carnatic music concert. Then we have done motif recognition in an alapna. Then we have done the scent filter banks on mridangam stroke recognition task. So finally, I'll show some results, so which will compare previous results with the pitch information and CQT features. So there I can say that my scent filter bank based capsule coefficients strongly will give a very good accuracy compared with other features. Because it is music is more related to tonic information. So finally, we have developed an automatic tool which will automatically segment the Carnatic music concert into different types of items. So if you load the 3 hours recording, so it will automatically segment that 3 hours recording into different types of items or different types of pieces. So if you move on to the tonic information, so already everyone has discussed about it. So in a concert, a performer can choose the tonic, and all remaining instruments or mridangam or whatever it may be, all percussion instruments are tuned to the same tonic. So in a concert, that tonic is fixed by the performer or a vocalist. So accordingly, all melody or what are the swaras he is singing, those frequency ratios will depending upon the tonic. So here, in any concert, if you are taking 3 hours recording, tonic is fixed. Throughout the recording, the tonic is maintained by using an instrument called drone. So drone or tambura. So if you by using this instrument, you'll preserve the tonic information. So here, lot of research has been done on tonic identification by Ashwin and Sankal. So they have used different types of features like pitch histograms and group delay based techniques and NMF activations, as well as multi-pitch techniques for identifying tonic information for any music segments. So now we have seen here, so this is a table where which explains there are 12 different swaras in Carnatic music. So any melody is a combination of these swaras, and in these swaras the tonic is maintained through shadja. So if tonic is around 138, according to 138, the frequency ratios of remaining swaras are maintained. So from this table we can see that the tonic of remaining swaras are completely depending upon the tonic information. So here the frequencies of these semitones or the melody, whatever in a set of notes in a melody, all are varying with respect to tonic information. So I can say that the frequencies of swaras, are varying with respect to tonic. So now we have seen there is a very strong relationship between Carnatic music and tonic information. So suppose if I want to model the Carnatic music for different types of processing tasks, so can I able to model using a general filter bank based capsule coefficients? So is it possible? So because general male filter bank capsule coefficients won't take tonic information into account. So here I have a slide which will compare male frequency capsule coefficients with scent frequency capsule coefficients. So in case of male frequency capsule coefficients, where you are placing the filters based on male scale, but in case of scent filter bank based capsule coefficients, I am placing the filter banks with respect to scent scale. So this scent scale is defined with respect to tonic information. So that's why this is the motivation behind choosing the scent filter bank based capsule coefficients, where it will take care of tonic information irrespective of whether it is a concert or tonic is 198 or 138. But that won't happen in case of MFCC features. So I'll give a brief introduction how CFCC features are extracted. So this CFCC feature extraction is similar to MFCC features, but except in case of MFCC, here you'll map the frequency to male scale, but here you are mapping the frequency information to the cent scale. So for this we need tonic information. So Ashwin paper has discussed about how to detect the tonic information for a concert. So he has reported 100% result on tonic because 3 hours recording, the tonic will be constant. So simply he has used the pitch histograms to find the tonic information for a concert. So now we have seen how important scent filter banks features for music. So now we have applied these scent filter bank based capsule quotients on different tasks. First we have applied on song identification in a concert. So if you have a 3 hours recording, I will give a label, direct locations for song segments. So directly you can access those song segments. Then we have done motif recognition in an alapna. So this work is earlier Vignesh has done motif recognition in an alapna, and he has used the pitch information. So and then we have applied same scent filter banks based capsule quotients on mridangam stroke recognition in Thaniyavartanam. So on this mridangam stroke identification, so Akshay has done a lot of work, and Ajay also has done a lot of work, where Akshay is using other features other than scent filter bank based capsule quotients. So this talk more concentrate on how important these CFCC features are compared with other features. So now moving to song identification. So before moving to song identification, I just wanted to tell what is the importance of identifying song locations in a concert. Suppose a concert can be 3 hours long. It is combination of these 4 different types of segments. That segment can be vocal, violin, composition, and Thaniyavartanam. So this combination can be repeated 4 times or 5 times. That will give you a 3 hours recording. So now, if you are able to identify composition segments in a concert, composition will be dealing with the melody information, and a lot of improvisation will be there within a composition segment, and all percussion instruments are included in the composition segment. So if I am able to provide automatic identification of the song segments in a big recording, so it will help for musicians who wanted to practice themselves by seeing the melody, and by extracting song segments, I can able to segment the concert into different types of items. Suppose I wanted to listen only the composition segments, not other than vocal, violin, Thaniyavartanam. So manually you have to drag the whole recording and you have to listen. But here automatically you can get the locations. So just go to the locations and try to listen to the melodies. So that is what intention is. So for this, so we have taken 50 live recordings of 10 musicians. So this table shows the database we are using for this analysis purpose. And if you take a male first singer, for his we have taken 4 live recordings. For his 4 live recordings, tonics are completely different. Each recording is performed with respect to one tonic. So 158, 148, 136, it's going on. So tonic can vary. From this table you can say that tonic can vary across the concert, and tonic can vary for every musician even. So we can't say that this musician can sing at a particular specific tonic. He may sing with other tonic in other recordings even. So for identifying the song locations, we are using the GMM models. So initially we'll train the GMM models with scent filter bank based capsule quotients. Once you train the GMM models for 4 classes, because a concert is a combination of 4 segments: vocal, violin, song, and composition. So I'm training my GMM model for 4 segments. Then I'll take the 3 hours recording, I'll find out the applauses, and then I'll extract the segments. Then I'll try to label all those segments as vocal, violin, song, and composition. So finally you'll get the index for only composition segments, where directly you can access those segments. So with this, so we have extracted, other than CFCC, we have experimented with MFCC and chroma FCC features even. So if you see from table, CFCC performs very good compared with MFCC and chroma FCC features. So we have a paper on scent filter banks on CMMR conference recently. So this paper will discuss more details about scent filter banks with respect to Carnatic music. So then we thought we can, because Vignesh is already done motif recognition on in an alapna using pitch information. Then we thought even pitch is normalized with respect to tonic. He has done that. So then we thought even scent filter banks, which works better for motif recognition. Then so everyone knows, because I'm very new to Carnatic music, so I know a little bit information about raga and this motif. So from Vignesh paper and from his help, so I thought that, so motif has a sequence of notes which are unique for every raga, and which defines the raga, what type of raga it is, or which defines the characteristics of raga. So if you are able to identify those motifs, unique motifs in an alapna, that will help you to identify what type of raga it is. So if you want to identify any raga, this is the first step we are doing. So if you are automatically identify motifs in an alapna or in a music segment, that will help you to automatically identify the raga information. That's the motivation behind identifying the or recognizing the motifs using different types of modeling techniques. So for this, Vignesh has one paper on same CompMusic workshop, and he has discussed about motific analysis and its relevance to raga identification. So where in this paper he has used pitch information, and he has used HMM models to recognize the motifs. So he has created the database. So there are 5 ragas. For each raga, he has labeled 2 or 3 phrases. So this is the total database. So I have extracted MFCC features, pitch, chroma, CQT, and CFCC features. So because of time constraint, I didn't put all technical details about CQT and chroma and everything. So among all these features, he has reported 65% accuracy for motif recognition. So I have 73% accuracy with scent filter bank based capsular coefficients. So from here you can see that CFCC dominates all other features. So for comparison sake, I have put a confusion matrix only with respect to pitch and the CFCC features. So here if you see, he's more curious, Vignesh. So here in case of pitch information, Shankarabharanam is more confusing here. It is more confusing with Kamboji, and even Shankarabharanam next motif is confusing with Kamboji. So, but in case of CFCC features, almost all my diagonal elements, this accuracy is almost balanced compared with this pitch information. So from this you can see that CFCC features works better for tonic related recordings. So then we tried for mridangam stroke recognition. So Akshay is not here, so I'm trying to give little bit information about this. So generally in Carnatic music, mridangam is a primary instrument. So it's a percussion instrument. So by using this instrument, we can maintain the thala information. So if you are able to identify or provide the transcription for mridangam instrument, that will help for musicians even, as well as for the students who wanted to learn mridangam. Or sometimes here, this is Guru Shishya Parampara. So we don't know, different, one guru will follow one different types of styles. If you are able to provide transcription, you can able to keep track of musical traditions even. That's the motivation behind this mridangam stroke recognition. So for here we have taken 10 different types of strokes. So as Akshay provided me information about these strokes, so we have 10 strokes. Among all these strokes, beam, cha, deem, dhin. These strokes are tuned to the tonic. Whereas these remaining strokes are not tuned to tonic. So I have taken these 10 strokes and I trained my model using HMM. So previously Akshay has done same mridangam stroke recognition with help of constant Q transform, and he has used the SVM classifier for recognizing the stroke information. So here I have used CFCC features, and I have used HMM model, hidden Markov model for recognizing the number of type of stroke information. So Akshay has created the database for 6 different types of tonics. So for each tonic, these are the different types of strokes, and we have all 10 different types of strokes. So here I have experimented with CQT and CFCC features, because here tonic matters. So MFCC anyway it won't take care about tonic. So that's why I didn't work with the MFCC features. So CQT, in this case I have done 2 different types of experiments. So I have 3 different types of tonic files. I have trained my HMM model on all tonics, and test with the HMM model with all the other tonics. I have trained my model all tonics and test with the HMM models. If that is the case, this is the accuracy with CQT and CFCC features. So then I have trained my HMM model on C sharp and test with the D and D sharp strokes. So in that case, so the accuracy has gone down, but still CFCC feature dominates the CQT feature. So from this I can say that if tonic is a very important for Carnatic music, if you wanted to model that Carnatic music segments, so we have to take care about tonic. So obviously this cent filter bank based capsule quotients will take care of this tonic information. So finally I just wanted to show a demo on segmentation of a concert. So if you give me a 3 hours recording, I'll segment that concert into different types of items. So first I'll explain what I'm doing exactly, then I'll show one demo. So assume that this is a 3 hours recording. I'm trying to identify applauses in a 3 hours recording. So based on applauses, I'll get the, between applauses I'll get the different types of segments. So these segments I'm labeling whether that segment belongs to composition or vocal or violin or taniyavartanam. So once I know the labeling for these different types of segments, I'll merge the segments which are belongs to the same raga. So there are a same composition, but in between because of improvisation there is an applause. Then my algorithm will give this is a composition 1 and this is the composition 2, but both are belongs to the same composition. So there what I'm doing, I'm taking care of raga information. I'll merge those two segments if they belongs to the same raga. So for that I'm using pitch histograms to merge the segments. So if you see from this figure, composition 1 and composition 2, both are belongs to the same raga. So then I'm putting those two segments into item 1. So finally I'll get the set of items in a concert and their corresponding locations. So nowadays a 3 hours recording is manually applause are marked and manually cut it into items for archival purpose or for making CDs. So here if you use this, automatically it will give you the number of items, automatically you can segment the concert even. So I'll show a demo. So for demonstration sake I have taken 30 minutes Vignesh live recording from Music Academy. So this is a half an hour live recording. So this red marks will indicate that applause locations. Once I know the applause locations, I know whether this is a composition, this is composition, and this is vocal and violin. So then I'm trying to identify this belongs to a single item, this belongs to a single item, but this vocal, violin, and one composition is there, so that is missing here. All three belongs to single item. That I'm doing by making use of raga information. So I'll play and I'll show. It's a composition. So this is the end of composition where you will be having an applause. Now it will play an applause. So it's an applause where that exactly that red mark is intimating. This is vocal, this is a vocal music. So this is end of alapna where you will have applause location. So with this I'll conclude. Thank you.